Hello everyone. Today let us discuss about numerical problems on electrostatic potential energy. The other video I have shown you only potential problems due to a point charge, due to some other charges, due to two or three charges. We have discussed about that. Now we are talking about potential energy of a system of charges. There are two topics to discuss about this in theory. One is potential energy of a system of charges in the absence of external electric field, and the second one is potential energy of the system of charges in the presence of external electric field. For that, I have taken these three problems. To do the problems, first we should know the new formulae which are useful for that particular numericals. So, these formulae you should learn by heart and write them five times. Close the book and again write them 5 times, and definitely you will learn. Today I have already written the formulae, or sometimes I used to write while I was teaching. To save the time in the YouTube, I have taken the formula already written. So here the first formula which you can use is this one, that is, this is potential energy. This is the potential energy of a system of potential energy of a system of two charges in the absence of electric field 1 by 4 pi epsilon naught q1 q2 by r12, where I have shown you here q1 is one charge and q2 is another charge. They are separated by a distance r12. Another formula which you should know, potential energy of the system of three charges in the absence of electric field. Now, if three charges are separated like q1, q2, q3, and the distances between them is r12, r13 and r23, and then the formula you will get u is equal to 1 by 4 pi epsilon naught q1 q2 by r12 plus q1 q2 q3 by r13 plus q2 q3 by r23. And for the same system of two charges which I have shown in the yellow color, if it is in the absence of electric field, this formula which I have drawn. But if it is in the presence of electric field, we have to use a different formula which I wrote here as the fourth formula. You can see here, this is the formula. Electric potential energy of system of n point charges in the absence, n point charges in the absence of electric field. This is for n charges. So sorry, I said something wrong here. So this is also in the absence of electric field for a pair of n charges. For the pair of n charges, that means there are we have here we have many charges. Many charges means we have what all we have is here. Yes, 1 minute. Yes. Okay. What all we have here is Q1, Q2, Q3, Q4, Q5, etc. etc. Totally we have Qn charges. Q1, Q2, Q3, etc. etc. Qn charges. This is also in the absence of electric field. In the absence of electric field, then the potential energy of the whole system of charges is equal to 1 by 4 pi epsilon naught sigma all pairs qj qk divided by rjk. Now this is all in the absence of electric field. Now I want to show you some formulas related to the presence of electric field. So this third formula which I have taken in the presence of electric field, that is which I am showing in a blue color. So this blue color, electric potential energy of a system of two charges in the presence of electric field, that is q1 v of r1 bar plus q2 v of r2 bar plus 1 by 4 pi epsilon naught q1 q2 by r12. This is in the presence of electric field, in the presence of electric field. And then I have written the another formula, that is for a dipole in a uniform electric field. This I am showing again with another color. Let's take for example that like red color. So this is the formula. The potential energy of an electric dipole in a uniform electric field. So this is U is equal to P cos theta 2 minus cos theta 1. Suppose the dipole was making an initial angle theta 1 and a final angle theta 2. So this potential energy P U is equal to P minus P cos theta 2 minus cos theta 1. If initially dipole was perpendicular to the field, then theta 1 is equal to 90 degrees, then theta 2 is equal to theta, let us say, then U is equal to minus PE cos theta. Because it is cos theta, we can say it is dot product of P bar dot E bar with negative sign. Suppose initially dipole was parallel to the field, then you will get initial angle theta 1 is equal to 0 and theta 2 is equal to theta, say, then U is equal to minus PE cos theta minus 1, then U is equal to PE 1 minus cos theta, 1 minus cos theta. So this is all about different formulae which are useful here. So now, okay, so with this formulae we can solve our problems, which I have written here. So we use all these formulas and then we can solve all our problems, whatever it may be, but we cannot solve everything in the YouTube. So for example, I have taken only three problems here. So let's see the first problem without wasting much time. Two positive point charges. This is the first problem which I have taken, that is two positive point charges, 0.2 microcoulombs and 0.01 microcoulombs are placed 10 centimeters apart. Calculate the work done in reducing the distance to 5 centimeters. What is the question here? Earlier, the two charges Q1 and Q2 are separated by a distance of 10 centimeters, but now the distance is reduced to 5 centimeters. Then how can we solve it? What is the work done? So let us write here Q1 is equal to 0.2 microcoulomb means 10 to the power of minus 6 coulombs. Q2 is equal to 0.01 into 10 to the power of minus 6 coulombs. Earlier the distance between them was 10 centimeters, Q1 and Q2, but now it is reduced to 5 centimeters. So then what is the work done? So what is the work done? So that is the question they have asked. Work done is equal to question mark. To find the work done, so let's take this one, that is work done is equal to that is change in potential energy. This is the principle, change in potential energy. That means change means final potential energy minus initial potential energy. So final potential energy minus initial potential energy. So I have already given the formula here. First formula, this is the formula 1 by 4 pi epsilon naught q1 q2 by r12. So final means we have to take that is 10 centimeters. Initial means we have to take the distance as final means we have to take the distance as 5 centimeters. Initial means we have to take the distance as 10 centimeters. So substituting in this particular formula, this formula, we will solve that problem now. So let us do that. Final KPE minus initial PE, that is equal to 1 by 4 pi epsilon naught q1 q2 by, or f I'm taking subscript because final distance, minus 1 by 4 pi epsilon naught q1 q2 by, or I, that is the initial distance. In both of them you can see this 1 by 4 pi epsilon naught and q1 q2 are common here, so we can take it as common out. 1 by 4 pi epsilon naught q1 q2, and the remaining will be 1 by rf minus 1 by ri. So substituting all the values, we will get now 1 by 4 pi epsilon naught, that is then q1 means this one 0.2 into 10 to the power of minus 6. q2 means 0.01 into 10 to the power of minus 6, and then the next thing is we have to take 1 by rf, that is 1 by 5 centimeters. That means when you convert it into meters, 0.05, because 5 centimeters is equal to 5 into 10 to the power of minus 2 meters. So you will get 1 by 0.05. Similarly 10 centimeters you will get 0.10 meters. So this is the substituting all the values here. So we will get here, that is 1 by 4 pi epsilon naught. Let me substitute the value of 1 by 4 pi epsilon naught. You all know that is 9 into 10 to the power of 9 into 10 to the power of 9. So let us take 9 into 10 to the power of 9 into 0.2 into 0.01 into 10 to the power of minus 6 into 10 to the power of minus 6, it will become 10 to the power of minus 12. 1 by 0.05 minus 1 by 0.10. Then we will simplify it. I am not doing calculations here. It will take quite a lot of time already, which I have calculated, which comes around 1.8 into 10 to the power of minus 4 joules. This is the work done. So this is the answer for the first problem. Okay. So then let's go for the second problem without wasting much time. So the second problem is this one. 2 electrons. Let me take a color for that. I'm taking the green color here. 2 electrons, each moving with a velocity 10 to the power of 6 meters per second, are released towards each other. What will be the closest distance of approach between them? So 2 electrons are released towards each other. So what can be the closest distance of approach between them? Why they asked like that is, electrons, both of them are negatively charged. Therefore they will repel each other. So to blink, how much can be the closest distance between them? So let us solve this problem. So let's come here and then solve our problem, that is the second problem. So let us think let us think R O be the distance of closest approach between these two electrons. This is one electron and this is one electron. Let us assume the distance between them is R O. And then at this distance, let us see the entire kinetic energy of the electrons changes into the potential energy. The entire kinetic energy of both the electrons, it changes into the potential energy. Therefore, let us write the kinetic energy formula, half mv square, that is half mv square plus half mv square for two electrons, that is equal to potential energy, that is 1 by 4 pi epsilon naught q1 q2 by r12. That is the formula which I used earlier, which I wrote here in this yellow color. The same formula we used, because this kinetic energy is converted, the kinetic energy is converted into potential energy. So we have used the same formula now, and then I will take 1 by half mv square plus half mv square, it becomes mv square, half plus half is mv square, then 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, and q1 means charge of the electron, q2 means charge of the electron. Distance between them we thought as RO, closest distance. Rearranging everything, we get RO is equal to 1 by 4 pi epsilon naught E square by mv square. So what I have done is I brought mv square this side, and then the E square to the E square I kept there only, but RO I have taken up like this, then mv square I brought down, then we got this formula. Okay, just I'm showing you because you have to understand it. Therefore you will get RO is equal to 1 by 4 pi epsilon naught, value you all know that is 9 into 10 to the power of 9. E means charge of electron, you all know 1.6 into 10 to the power of minus 19 coulombs, but whole square divided by mass of electron, we know 9.1 into 10 to the power of minus 31 kg, and R, that is the distance, sorry, not the distance, velocity here, RO we have to find. This is not R, V. Let me nicely write it, because we get confused with the V and R. mv square, yes, it's V square. V means velocity. Velocity is given in the problem as 10 to the power of 6. Here it is a square, so 10 to the power of 6 whole square. And then after that, okay, let's continue. We will simplify it, and after doing the calculations, which I am not showing here, because it may take quite a long time, that is equal to 2.53 into 10 to the power of minus 10 meters. This is the answer. So this is the answer for this second problem. So the second problem, what can be the closest distance between the two electrons? So this can be the closest distance, that is 2.53 into 10 to the power of minus 10 meters. After simplifying, you will get that one. So let's see the third problem. So the third problem. So let us take, I'll show you with the color. This is the pink color which I'm using here. An electric dipole, because let us take one problem with the dipole also. An electric dipole of length 4 centimeters, when placed with its axial axis, making an angle, just a minute, uh, here there is a spelling mistake and is missing here. Okay, so yes, I have rectified it. Making an angle 60 degrees with a uniform electric field experiences a torque of 4 root 3 Newton meter. Calculate the magnitude of the electric field, potential energy of dipole if the dipole has charges plus nanocoulombs and minus plus 8 nanocoulombs and minus 8 nanocoulombs. What they have given, there is a dipole, that is plus q and minus q. Dipole, you all know, two equal and opposite charges separated by a distance is called as dipole. So plus q is 8 nanocoulombs and minus q is minus 8 nanocoulombs, and the length of the dipole is 2a is 4 centimeters. Then it is placed in the external electric field. Then it makes an angle 60 degrees with the electric field. Then it experiences a torque of 4 root 3 Newton meter. We have to calculate what is the electric field there. And second thing, we have to calculate potential energy of the dipole. So we already, I have shown you here, because this is the potential energy of the dipole in a uniform electric field. In addition to that, they also asked us to find the torque. So let's go and solve this third problem. Yes, let's solve this third problem. So now this dipole has a length of 4 centimeters. That means let us write first plus q and minus q. That is plus q is 8 nanocoulombs. That is 8 into 10 to the power of minus 9 coulombs, minus q, that is minus 8 nanocoulombs, that is minus 8 into 10 to the power of minus 9 coulombs. Distance between plus q and minus q is 4 centimeters. Yes, 4 centimeters. That is 4 into 10 to the power of minus 2. That is 0.04 meters. And it makes an angle theta is equal to 60 degrees. And it experiences a torque tau is equal to 4 root 3 Newton meter. So this is what all they have given in the problem. So let's calculate the dipole moment. We all know P is equal to Q into 2A. Q means any one of the charges, that is magnitude of the any one of the charges. 8 into 10 to the power of minus 9 into 2A, that is 0.04, and then we will get, after simplifying, you will get 8 4s are 32, and then after rearranging the powers you get 0.32 into 10 to the power of minus 9 coulomb meter. This is the dipole moment P. So let's calculate the first point, that is number 1. So they asked that is tau is equal to P E sine theta. They asked us to find what is the electric field. You have to find the electric field here. So electric field E is equal to tau divided by P sine theta. Tau means torque, which they have given in the problem as 4 root 3, and P is the dipole moment, 0.32 into 10 to the power of minus 9, and sine theta, that is sine 60. Sine 60. Okay, so let's simplify it. That is equal to 4 into root 3. Root 3 means we all know 1.732 divided by, and that is okay, better not to take as root 3, because we can cancel it. Let us keep it like root 3 only. because calculations will be simple. 4 root 3, because the sine 60 is root 3 by 2. Root 3 we can cancel. So I'm keeping it root 3 like that only. Then after that, p means 0.32 into 10 to the power of minus 9, and sine theta is root 3 by 2. Then this 2 will go up. Then we will get 4 root 3, sorry, 4 root 3 into 2 divided by 0.32 into 10 to the power of minus 9 into root 3. So you can cancel root 3 and root 3, and 8 divided by 0.32 into 10 to the power of minus 9, this one. So then after that, once you simplify, you will get the answer, that is 2.5 into 10 to the 2.5 into 10 to the power of 10 newtons per coulomb. This is the electric field. So this is the answer for the first part. What is the electric field, they asked. So this is the electric field, and then the second part thing they asked is find the potential energy. So the potential energy for a dipole, I have written the formula here. You can see here, that is Pe cos theta 2 minus cos theta 1. But initially, if it is initially dipole is perpendicular to the field, then it will be minus Pe cos theta. So let us use that formula now and find the potential energy. That is U is equal to minus Pe cos theta. Then that is P we already calculated, that is 3.32 into 10 to the power of minus 9, and E value just now we got, that is which I kept in this pink color, 2.5 into 10 to the power of 10, and cos 60. Then we get minus 0.32 into 2.5 into 10, because 10 to the power of 10 minus 9, it becomes 10. Cos 30 is root 3 by 2. Then once you simplify, because if I simplify here it takes quite a long time, and finally you will get the answer minus 4 joules. So this is the potential energy of a dipole in a uniform electric field. So with this I have calculated the 3 problems. So whenever the problems are given, the only thing you have to know is the formulae, and then use the formulae, learn them carefully. I have kept all the important formulae for the potential energy here. You can learn them and then you can use this formulae. Okay, let us solve these problems, and don't get scared to solve the problems. You will definitely do very well in the exam. Nothing to be scared about these problems. Only thing is you should be confident with the theory as well as the formulae which are useful to solve these numerical problems. We'll meet in the next video with some more numericals. Till then, bye. God bless you all.